This is lesson 4.6, Intermolecular Forces. Remember that intermolecular forces are forces that exist between molecules. The first type of intermolecular force is called van der Waals. Van der Waals is the weakest intermolecular force, and it only occurs between, well, actually it occurs in all molecules, but it's the only intermolecular force in nonpolar molecules. And if you think about an atom, at any one time, there could be more electrons on one side than the other, which creates what we call an instantaneous dipole, where this side has a partially negative charge and this side is partially positive just for a second. Well, if another atom comes near that atom, these negatives will repel the electrons in the second atom, which also creates a dipole in this atom, which is called an induced dipole. And so these two atoms are attracted to each other. However, it only occurs for a few seconds, and so it's a very weak attraction. Van der Waals forces will increase as the number of electrons increases. So as the molecule gets bigger, van der Waals will get stronger. Molecules that only have van der Waals forces of attraction have low melting points and low boiling points because, again, this is a weak force, so you don't need a lot of energy to break them and move the molecules apart, which leads to lower melting points and lower boiling points. The second type of intermolecular force is dipole-dipole attraction, which is stronger than van der Waals and only occurs between polar molecules. Polar molecules, remember, have a permanent dipole, so the negative end of one molecule will attract the positive end of a neighbor molecule. This dipole-dipole attraction leads to stronger intermolecular forces, so the melting and boiling points of polar compounds are higher than nonpolar. The more polar the substance, the higher the boiling point. The last type of intermolecular force is called hydrogen bonding, and for hydrogen bonding to occur, which is really just a strong dipole-dipole attraction, you have to have a hydrogen that's bonded to either a fluorine, nitrogen, or oxygen. Hydrogen bonding is the strongest type of intermolecular force. It's a dipole-dipole interaction between the hydrogen of one molecule and the oxygen, nitrogen, or fluorine of another, because of the large electronegativity difference between hydrogen and fluorine, oxygen, or nitrogen. So because fluorine, oxygen, and nitrogen are so electronegative, it pulls the electrons from hydrogen, which is very, very small, and so hydrogen is left unprotected, which creates a very, very large dipole. And hydrogen bonding leads to compounds that have extremely high melting and boiling points, and is very important in water. So here's an example of water, and when water gets colder and starts to solidify, the hydrogen bonding takes over, and the hydrogen of one water is attracted to the oxygen of another in this very strong intermolecular attraction, and it actually leads to water being less dense as a solid because it sets up this rigid hydrogen bonded structure. Also, hydrogen bonding is important in DNA, where it holds the DNA nucleotides together.